Okay, in this video, I want to talk about integration by substitution. And we know integration, or antiderivative, undoes the derivative. So each of these techniques of integration basically undo one of our techniques of differentiation, and integration undoes the chain rule. So I just want to give a quick example of a reminder of what the chain rule does, and then show how substitution undoes it. So if we wanted to take the derivative of something like 1/2 sine squared of x, that's not a very good 2, well, sine squared, and we know we can take the constant out front, right? So what we're really looking for is the derivative of sine squared, all right? Now, this is the composition of two functions, f of g of x, right? If we put one function into another. So what two functions is this the composition of? Well, the outside function, the whole thing is being squared, and then what's being squared is sine x. So we would say that the outside function is x squared, and the inside function is sine of x. So that when you put this in for x, we get sine squared. Now, the chain rule tells us how to find the derivative of something like f of g of x. And it says we take the derivative of the outside function, and we leave the inside function in there, and then we multiply by the derivative of the inside function. So if we're using this f and this g, then we know that f prime, derivative of x squared, is just 2x. And that's with x, so if we have f prime of g of x, then we would just place x with sine x, so we end up with 2 sine of x. And then g prime, if g is sine of x, is going to be cosine of x. All right, so if we put it all together like this, we get 2 sine of x times cosine of x. That's just putting this together with this. All right, so that is that derivative. So we wanted to find derivative of 1/2 of that, so we have 1/2 times 2 sine of x times cosine of x, and that just gives me sine of x cosine of x. All right, so as I said at the beginning, substitution undoes the chain rule. Well, let's first just what we know from the fundamental theorem of calculus. We know that if the derivative of sine squared, of 1/2 sine squared is sine x cosine, then by the fundamental theorem of calculus, we know that the antiderivative, or the integral, of sine x cosine is going to be 1/2 sine squared. But remember, the antiderivative is not just a particular function, it's a family of functions, because any constant added on to 1/2 sine squared would have given us the same derivative. In this particular case, the constant was 0. We don't usually write plus 0, but if we had plus 1 or plus 10 or minus 100, whatever, we would have still gotten the same derivative. So the question, though, here is, well, how do I, if I didn't already know that the antiderivative was 1/2 sine squared, how do I find it? And the key here is to recognize this relationship. We have this g of x right here, and we have this g prime. So how do we see that in something like this? Well, here is a function, we call it g, and here is its derivative. All right? So when we have an integrand where we have a function and its derivative, that's when we're going to want to use substitution, because something like that could have been the result of the chain rule. All right, so let's look at how we would, for this particular case, how could we get this same answer if we started with this rather than starting with this and getting the derivative and then just kind of knowing, well, if I go backwards, then I get the antiderivative. So what we're going to do is we're going to let u equal, u is going to be some function of x. In this case, it's going to be sine of x. And then the derivative of u with respect to x, that's also known as g prime, and that's going to be cosine of x. All right. Now, just because I want to replace, so I'm already going to replace this part right here with u. I want to replace the rest of this whole thing with du. So this is all in terms of u. Notice if I just multiply through by dx, then du gives me cosine of x dx, right? So du can replace this whole part, u replaces this, and my new integral in terms of u just looks like u du. All right, now this is an easy one to figure out from our basic antiderivatives. We know that's just going to be u squared over 2 plus c. But of course u was sine x, so that's sine squared x over 2 plus c. And of course, that's the same thing as just bringing the 1/2 out front. 1/2 sine squared of x plus c. All right? So this is basically how substitution works. We identify a function, we call it u. We identify the derivative, we call that du. We do this substitution of u and du for the original one in terms of x. And then at the end, we just have to substitute back to our original function of x. All right? So let me just summarize what we just said here. So if I want to find the antiderivative or the integral of something of the form f of g of x times g prime, right? This is what we get when we take when we use the chain rule. Well, technically it's f prime, but let's say it's f and the antiderivative. Let's say that if I take the derivative of f, then I get of big F, then I get little f. So then this is going to be f of g of x plus c, where big F is the antiderivative of little f. All right. So another way to think of little f is that it's big F prime. But again, using this other notation, if we let u equal g of x and du equal g prime of x dx, all right, so we're going to do that substitution into this up here, then we get the integral of f of u du. All right, so again, we've transformed this into something in terms of u. Then that's going to give me the antiderivative, right, big F, in terms of u plus c, and then we want to put g of x back in for u, so I end up with f of g of x plus c. All right, so this is just kind of the general idea that if we can do this substitution, we get the antiderivative. Let me do one more example just to help kind of solidify the idea. So let's say we want to find the antiderivative of x squared plus 1 cubed times 2x dx. Now, of course, we could expand this out and then distribute the 2x to all the terms, and then it would just be the antiderivative of a polynomial, which is fairly straightforward, term by term. But expanding that out that's some work, to cube that out and then to distribute the 2x. Notice, again, though, that here I have a function, x squared plus 1, and 2x is its derivative. So we want to call this u, and this whole thing here du, right? So I would let u equal x squared plus 1 du. Take the derivative of this, I just get 2x dx. All right, so I'm going to replace that whole thing with du, and just this part in the middle here, right? So I'm going to have the integral of u cubed, right? So you can kind of think of up here, if I'm taking this integral, f was x cubed. All right, so I'm replacing it with u, so I just have u cubed, and then that whole thing is du. And again, what we're doing is we're reducing this to a very simple antiderivative to evaluate. It's just u to the 4th over 4 plus c, and then we just need to take our u. We need to take what's x squared, put it back in here for u, so we end up with x squared plus 1 to the 4th over 4 plus c. And again, by the chain rule, you could take the derivative of this and you would get back x squared plus 1 cubed. Right? That's kind of this generalized power rule multiplied by 4. That 4 goes away, reduce this to a 3. That's where you would get to x squared plus 1 cubed. For that part of it, that would be our f prime of g of x. And then we multiply by g prime, we would get to 2x. All right, so this is just a basic introduction with a few straightforward examples. I will have another video that will go through a little bit more complicated examples of using the method of substitution.